Good evening, we enthusiasts. Today we are going to start a new chapter, and that's momentum and collisions. So in my previous session I have talked about consistency, about how to gather that momentum, on how to overcome that barrier of procrastination. And once you get that momentum, once you get moving, that's it, you are set, and you will start following the same routine, whatever timetable I talked about in my previous session, about the scheduling, on how to manage time and how to schedule tasks. So once you gather momentum, trust me, once you have overcome that barrier of procrastination, the pain is over and everything becomes just a routine, it becomes a habit, and you get going. But today we are here to talk about the momentum in physics. And like this Hulk jumping out here, he has a lot of momentum, and we are going to see a lot about impulses as well. So a lot of people do not devote so much time on impulses and momentum, but there are a lot of questions in JEE Mains, JEE Advanced, NEET examination, etc., where a lot of questions are asked on momentum and impulses and average forces. So that's what we are going to discuss today, and I hope you will stay till the end to understand each and every bit of it, and you will solve all the problems today. So welcome aboard. This is Shreyas here, your master teacher for physics at Vedantu, going live. So I have been teaching for quite some time, and I have produced amazing results which I intend to do with you all. So if you are new to this family, if you are new to this channel, first of all, welcome to We Enthuse. We are a family. We are a set of people who are self-motivated. We are driven to achieve one common goal, and that is to crack our competitive examinations, to score well in our board examinations, and also to make everyone around us proud, and we are going to enjoy while we learn. So that's the whole motive of this channel, and I'm pretty sure all the existing members of our family will agree to the same. So welcome aboard, and this is a bit of my profile, and you can also follow me on Shreyas_Vedantu. That's my social media handle on Instagram. So if you want to connect with me, go ahead, just follow me, send me messages, tag me in whatever post you feel that you would love to tag me into. So do that, all right? So if you are new to this family, there's one more thing you need to do to become a member of a family officially, and that is to hit the subscribe button, the red button out there below. So just go and hit the subscribe button, and do not forget to like this video, because without you liking this video, you're not going to get recommendations from this channel, and you might miss on some amazing tips, tricks, and all the amazing lectures, the sessions that we conduct for you guys, so that you crack your examination and achieve your goal. So welcome aboard Techno, Ryan, Lone, Suhas, Kritho, Hardik, welcome Arthi, welcome, good evening. I was just reading through all your chats. It's amazing. Wow, we have a tree as well. Hi Jumna, hi Juhi, hi VSG, hello everyone, hello Fida, hello Science Priya, hello Pranuti, hello Janvi, Devendra, Tanmay, Uncharted, Shabana, welcome aboard. So what an amazing crowd we have today. So I hope you guys know that generally I'm going to keep it Monday, Tuesday, Wednesday as 11th standard portion, Thursday, Friday and Saturday as 12th standard portion. You might see some motivational sessions, some special sessions in between, but that's special sessions. But in general, the first half of the week will be 11th standard. So all the 11th standard students, be happy. We are going to cover the 11th standard portion, and all the 12th and the dropper students, remember, you can attend the entire week, because you need to revise the 11th standard portion as well as the 12th standard portion. All right, so that's how the schedule generally is going to be in physics, and I'm pretty sure it's almost a similar thing in chemistry and maths as well. So I hope you have already liked the video and already subscribed to our channel. And now let's get going. I hope the Josh is high, guys. I hope the Josh is high. Vemula, Techno, Sneha, Dinesh, guys, you need to keep the chat box really active, really active, and also at the same time pay attention. So come on, respond to all the chats, respond to all the new members of the family, welcome them, help them, and also whenever I ask you questions, do respond out there. All right, very good. The Josh is high. Very good, excellent. So let's get going. Yes, Ashutosh, I know you messaged me on Instagram. Yes, I know you. Yes, hi Ruchir, can a dropper give KPT? Yes, why not? Just check the site, just check the the last deadline and your birth date and all those things, just check it out. I'm pretty sure you will be able to get it. Sneha, just check the other videos in the same channel. One of the Telegram links will work, and in case it still doesn't work, what you can do is, in the Telegram link there will be t.me somewhere, t.me, T for Telegram. So just replace that letter, alphabet T, with the word telegram.me and it should work. That's the general workaround for making that link work. Alright? Okay, I hope that's fine. Welcome Fida, you are from Kerala. Very good. Loan is from Kashmir. Very nice. Why can't I find you in 1 rupee micro course Naga? You will find me in free micro courses Naga. So once you enroll into pro subscription, you will find me. No worries. Alright, so let's begin. Yes, Suhas, I saw. So when we see objects in motion, just like the Hulk we saw, alright, once they are moving, we know they possess some property called as momentum. Momentum is that effect of mass as well as velocity, and it is a vector quantity. So a heavy object will have some momentum once it is in motion, but the same object once at rest will have no momentum. Similarly, a small object will have less momentum for the same speed, and if that small object moves with very high speed, then it can have the same momentum just like the heavy object moving with slower speeds. So how do we define exactly the momentum? And I have told you this before, but just for all the newcomers out here, if you have a mass and it is moving with certain velocity v, then we define momentum. The symbol for that is p, is equal to mass times the velocity, but it's a vector quantity, and the direction of the momentum is always the direction of the velocity. So if the velocity is here, yes, the momentum should also be in the same direction. It cannot have some weird direction, obviously. And obviously the unit can be kg, meter per second. Kg is mass, meter per second is velocity, that's the unit, and it's a vector quantity. So these are some important pointers. Now, once you know this simple definition, this is going to lead to very, very big problems in the next lecture, like conservation of momentum, and in today's lecture, average forces and impulses. So lot of tricky questions, JEE advanced type, NEET plus problems like and JEE mains plus problems. So all these kind of questions, the very good questions I have collected, and I'm going to deal with these kind of questions by the end of today's class. Now that we know what is momentum, let's think, can we actually change momentum? Is it possible to change momentum? And if you scratch your head a little bit, you will understand, yes, you can change the momentum. And what do you need to do to change the momentum? Apply a force. The moment you apply some force, your momentum can be changed. If there are more bodies, you apply forces on each and every body, and each and every particle's momentum can be changed. That's how you do that. Alright? Yes, uncharted. Correct. Menti will also be there, Devendra. Yes. So Hoin, yes, we are doing one shot kind of videos, but they are not called exactly one shot. We are going to do it in multiple shots, because I don't want to give you everything in one shot, because you will not be able to understand it in one shot. A lot of people do that, but trust me, it's not the right way, because we have a lot of time. If there was only 2 weeks, I would have done one shot, but we have 2 months, so I'm not going to do one shot. Understand? Alright, so momentum can be changed by applying a force. So let's talk about it. And in fact, Newton's second law told us exactly about how quickly momentum changes. Newton's second law said the rate of change of momentum is the force which you apply on it. So the force that you apply on a body is nothing but dp by dt. This was nothing but your Newton's second law, and this was called as the rate of change of momentum. This was the rate of change of momentum. Now if I rearrange those words little bit, alright, let me rearrange this expression and let's see what do I get. I will get dp bar is equal to f bar dt. So change in momentum is force multiplied by the time. So think about it. Understand, if my force was constant, alright, if my force was constant, then the total change in the momentum will be the force into the time itself. Instead of dt, it will be delta t if F is basically a constant. If force is constant, then this is what is going to hold true. I hope you agree with this statement. So more the force, more is the change in the momentum. Same force applies for a long time, then also the momentum will change for by a good amount. Imagine this striker hits the ball for a long time. Obviously momentum will change by a great deal. Also, if large force applies for a small time, then also the momentum will change by a good amount. So that's why it's the product of force into time. That's one way of looking at it. Now you might be like, sir, what if F is not a constant? If F is not constant, you would have guessed it by now what we should do. Guys, come on, think about it. Instead of just writing it as delta t, you have to integrate it. Yes, the total change in momentum will be integration of the smaller changes, so it will be F dt. So that's how it will be when force is not constant. Very, very important slides. You should know all this. I hope you guys are understanding all this. We do not know when, so do not fall for the rumors. Do not worry about it. All right. I hope this is clear. Is this clear? Yes, Janvi, this is for 11th standard only. 11th and 12th both. Yes. All right. Clear, everyone? Everyone, let me know in the chat box. Come on, come on, come on. Put it up. Is it clear? All right. So remember all these formulas. Also make notes because there are going to be problems on integration and derivatives very soon. So keep a note of it. Keep a note of it. Very good. Thumbs up. Very good, guys. So now let's go ahead. Let's go ahead. Now that we know momentum can be changed by applying force for some duration, what is that change in momentum called? So I'm asking, what is change in momentum called? We know how to change momentum. What is that change called? You would have guessed it. That is called as impulse. So when you change the momentum, that change in the momentum is called as impulse. It's a vector quantity. So impulse is nothing but, just simply put, change in momentum, and it's a vector quantity, obviously. And since it's just change in momentum, the unit will be just kg meter per second. All right. So that's the unit of it. What's the symbol? Some books use the symbol J, some books use the symbol I. It's totally up to you which symbol you want to use. So let's say I stick with the symbol I. So impulse I will be just simply put change in the momentum. That's it. So change in momentum, which is nothing but final momentum minus initial momentum. Does not matter what happened in between. Just look at the final and just look at the initial. That means what do you need to use? Think about it. Vector subtraction. That's why I have taught you that in one of my previous sessions. So you can use vector subtraction to find impulse. Also, in the previous slide, I told you what is change in momentum. Change in momentum is nothing but F into delta t, or you can also use integration. F dt is integration. This is when F is constant. All right, and this is when F is a variable, so then you need to integrate it. All right, so this is how impulse has been defined. Understand that. So very, very important slide. Also, you get an alternate unit of impulse from here, because force has a unit of Newton and time has a unit of seconds. So you can also write it as, you know, Newton into seconds. So both units are equivalent of each other. So don't worry, I'm going to take up some numericals and then you will get a hang of it. Only then you will probably get some good confidence in this. First, briefly, I'm explaining all the theory pointers so that you make notes. You are going to remember all these formulas which are useful for solving those problems. Clear? Very good, very good. Now understand if a large force acts, then the impulse is more. Imagine Dhoni hitting the shot, large force, that will create big impulse. All right, and if you apply the force for a long time, the ball sticks to the bat for a long time, then also the impulse will be more. Understand? So if time is more or the force is more, the impulse is also more. Remember this. That's what this tells me. Great. If this is fine, let's go ahead. Now, Because we saw integration, immediately it should enter your head. Oh, integration is related to area under the graph, and derivatives is related with slopes and all those tangents and all that stuff. So the moment you saw integration, it should have probably clicked your mind that there will be some kind of area involved. So imagine if we have a graph of force versus time, all right, force versus time. Then if I measure that area over here, this area under force versus time graph will always give you impulse. Remember that. So we just saw that impulse was nothing but integration of force with respect to time. That is what this is. So area under force versus time is going to give you impulse. All right, I hope this is also clear. And impulse is nothing but also the change in the momentum. That's what we are seeing. I hope you're making notes of this. Make notes of this. Is everybody understanding very simple stuff? I hope you're making notes. Very good, Ryan. Very good. Krito, you're helping a lot. Very good. Yes, Janvi, I will take few questions in the end. And we are going to keep special sessions for advanced questions as well. So understand, Janvi, there are some students who need to scale up from the basics to the higher level. So slowly the level will go up and very specific advanced sessions will also be conducted. So stay tuned. All right, let's go ahead. Okay. Now, what do you call a force which changes the momentum very quickly? Imagine a force which changes the momentum very quickly. Do you know what the answer is? Come on guys, let me know. Come on, what do you think? Impulsive force? Yes. No, Devendra, it's not called impulse. No, Fida, it's not called impulse. Impulse is different. Impulsive force is different. That is why you should attend all my classes. Because lot of people make always some mistake. And that is why every bit of it, whatever I tell you, is very important. So no point just attending recorded sessions or just missing and just looking at the numericals. No, you should attend the theory sessions as well. So understand, impulse is just change in momentum. But a force which changes the momentum very quickly is called as impulsive force. Like this bat hitting the ball, alright, very quickly the momentum has changed. Tak karke, within fraction of a second. It's a relative term. There is no hard and fast rule that, oh, only if it is less than 1 second, then it is impulsive. Nothing like that. It's a relative term with respect to the other forces. You'll be like, sir, what is the other force over here? Well, the other force over here is gravity. Do not forget, during this motion, gravity was also acting. Even gravity would have changed the momentum, but it would have hardly changed the momentum. Because gravity will change the momentum of the ball very slowly. You have seen projectile motion. It takes so much time to change the momentum. But the force by the bat is so huge as compared to the gravity that it can change the momentum very quickly. So with respect to gravity, it is impulsive force. I hope this is clear. Yes, RIP bat. Yes. Yes, Anish, why not? Yes, we are going to give you extracts for this chapter as well, just like the previous chapters, which will be complete formulas and hidden tips, tricks, graphs, everything in one sheet. Yes, everything in one PDF is what we are going to give you for your exam preparation. Do not worry. All right. Now, what is a non-impulsive force? What is a non-impulsive force? A non-impulsive force is that force which hardly is able to change the momentum even if it acts for a decent time. Just like the spring force. Look at that. The block comes around, say, and hits it, compresses, and then it goes back. Look at that. The momentum changes, but it takes so much time for the block to change the momentum. So the spring force is obviously a non-impulsive force. So all those soft cushioning forces. So whenever you see cushioning, you can treat it like non-impulsive. Whenever you see that sudden change, that is impulsive. I hope this is fine. All right. So understand the graphs for impulsive and non-impulsive look slightly different. Look at that. Look at that. Look at these both graphs, 1 and 2. Which one do you think should correspond to the batsman hitting the ball? Which one do you think is batsman hitting the ball? Is it 1 or 2? What do you think? Is it 1 or 2? Yes, very good. It's 2. And that spring getting compressed and then it is going back. What is it? Is it 1 or 2? Come on guys, the spring getting compressed and then going back. What kind of graph should it resemble to? 1. Okay. Now look at that. It is possible, just an example, it is possible that both the areas are same. If both areas are same when the graph is force versus time, what is same if area is same? If the areas under both these graphs are same, what will be the same? What will be same, guys? What will be same? Come on, answer in the chat box, I'm reading it. What will be same if areas are same? Come on, let me know. Okay, Uncharted has said it. Jumna, is it P or delta P? Think again. Yes, impulse will be same. IT aspirant, I have already started sessions. Please do not interrupt. I have already started those sessions, but they are not called one shots. We have a lot of time. I cannot keep answering the same thing again and again. You should understand, guys, if you want one shots, please, you are free to go anywhere else. But here we are not going to do one shots because I have made it very clear again and again that we are going to focus properly on all the problems and all the theory and all the pointers. If you want one shots, you are free to go anywhere else, but understand we are going to do things properly because we have time. If we didn't have time, yes, I would have definitely done one shots. Understand that. Okay, so now here is the thing. Impulse is the same. So understand, lot of people have this misinterpretation. Oh, if the force is more, then it is impulse. It has lot of impulse. No, not necessarily. Maybe the force is not so huge, but it acts for a longer time. It could have the same impulse. So that's a basic difference between these graphs. All right. So I can label this one as impulsive, and I can label this as non-impulsive. Okay, so I hope you're making notes of this. You can draw these graphs quickly and you can label one of them as impulsive and non-impulsive. All right. Krito, the block's velocity won't reduce instantaneously. It will take a lot of time. Yes, it decelerates, but decelerates slowly. It's not like the velocity will change from 10 meters per second to 5 meters per second in 0.1 second. No, it will change slowly. See, understand, non-impulsive does not mean velocity won't change. It will change, but slowly. I hope this is clear. Yes, correct. I think Uncharted and Suhas have said that. Very good, guys. You guys are very smart. Yeah, you guys are thinking like me. Bahut badhiya. Keep these questions coming. Keep helping each other. You guys are thinking very good. Very good. Very good. So now, before we start problems, let me tell you about the subscription-based courses. So we're going to start with the problems now. So before that, let me just quickly tell you about our pro subscription-based courses. So guys, understand what is pro subscription. In pro subscription, you get enrolled in a batch. Now, if you join now, you will be enrolled in a crash course because the long-term batches have started already, and we have an extensive crash course for the 11th, for the 12th, for the dropper series. All right, and then apart from that regular batch, what you get in the regular batch, you get notes, you get recordings, you get doubt solving, you get the Telegram groups where you can interact with each other as well as the teacher, and the test series have national ranking and all that stuff. All right. Apart from that, you also get the special courses like KBPY course, the Olympiad courses, the micro courses, any book discussion course or numerical course, and so on and so forth. And if you do not know, those of you who are very new or probably have not heard this, I have already started a numerical course for JEE and NEET, and they are good level problems. There are a lot of students out there, and the feedback has been really great about that course because the questions are not from any book. Yes, they are from my own question bank. My own question bank questions, I am taking it up in the micro course, which has already started. Only 2 lectures are over, but you can always watch the recordings. So understand, this course is going to be beneficial for all the JEE NEET aspirants. So if you are already enrolled in the pro subscription, go there and join the numerical course and many other courses by many teachers. And also you get the option of Hindi, English in many courses. So keep that in mind. And obviously you get report cards and stuff like that. So you might be wondering what is the price for that? Well, for droppers, here is the price for 6 months. Actual price is 51,000, but after discount it becomes 40,000. So a huge discount of 20% is what you get. And if you look at it per day, guys, it comes out very reasonable of about 227 rupees per day. That's for the droppers for the next 6 months till your JEE advanced exam. For the 12th standard students, if you take it for 6 months, it's 39,000, and you get all the benefits just what I told you. After discount, the price comes down 20% off, so 31,200, and per day price is 173 rupees, very reasonable again. And for the 11th standard students, again, if you take 6 months, it's 24,000, but after discount it is just 19,200, and per day cost comes out to be 107 rupees. That's quite reasonable. So how do you get all this? You need to click on the link, and also the link which will be shared in the chat, and so many other places you can find it. In fact, you can use this coupon code anywhere on the Vedantu website and you are guaranteed some kind of discount. All right, so just use this coupon code SHHPRO. The link is in the description box. You can click on it after the session is over. All right, so let's begin with a problem. I will start the problem now. All right, so guys, are you guys ready now? Let's start the problem. Yes. Suhas, the question banks PDFs will be there in the micro course only. So all the PDFs that I told you, sorry, all the micro courses I told you, the PDFs are available once you enroll into the pro subscription. It's for free of cost. And once you enroll into the micro course, as soon as the lecture is over or the session is over, you get the PDF. You can download it, you can take print out, do whatever you want with it. All right, so let's start. A ball is hit with a 300 Newton force. High speed cameras show the contact lasted for 0.02 seconds. What is the impulse? So let's do this. What is the impulse? So the force is 300 Newton. Time is also given. What is the impulse? We just saw impulse is nothing but force multiplied by time for which it acts. That's what we saw. And what is the force acting on it? Well, that is 300. And what's the time for which it acts? It's 0.02. So guys, what should be the answer? Yes, very good. I can see that. Very good. 6 Newton second. Already most of you have got it. So that is the correct answer, guys. I hope this is clear. So that's the impulse. Very good. Let's go to the next question then. This was beginner. Just to give you warm up. A lot of people ask me, sir, why do you give a simple question always at the beginning? Just to make you feel confident, just to make you feel comfortable, nothing else. If I give you a very scary problem, then probably you will run away. All right, so let's do the next problem. How about this? A ball of mass 500 gram is projected with a speed of 10 meters per second. It hits a wall and reflects back with half the speed. What is the impulse by the wall on it? I'll give you 1 minute to solve the problem, and let's see how many of you get the answer. Timer has started. Timer has started. Timer has started. Come on, guys. Come on, come on, come on. Okay, Hoin, don't worry. You will also become nerdy soon. Staying with us. Very good, Ryan. Come on, come on. Start solving the next question. Give the answer in SI units. You have around 35 seconds. Come on, guys, come on, come on, come on. That's in grams. Be careful. A lot of people have given the wrong answers. Most of you are giving the wrong answers. Time is up. Time is up. That's the sound. All right. So let's see how to solve this question. And here it goes. The mass of the ball is 500 grams. So this is basically 0.5 kg. Okay. The velocity is 10 when it hits it. So it hits it with a speed of 10 meters per second, but it reflects back with half the speed. That's very critical. When it comes back, the speed is only 5 meters per second. Now, if I ask you, what is the impulse? We know it is just change in momentum, which is final minus initial momentum. So what is the final momentum? Look at it. velocity is negative, right? Because it is going to the left side. I can assume the right side to be positive, so automatically the left side will be negative. So using the sign convention, final momentum will be 0.5 is the mass into velocity will be minus, how much is it? Minus 5 and minus, all right, so this is the final momentum. And what is the initial momentum? Think about it, it will be 0.5 multiplied by 10, of course. So think what will happen, guys. You can take 0.5 common, minus also common, and you will have 5 plus 10. It will not subtract. A lot of people would have subtracted forgetting that there is a sign. Yes, most of you got it wrong then. I hope this is clear. So 5 plus 10, 15. 15 into 5, how much? 75. So that point is there, do not forget, it is minus 7.5. But understand, it's only about the magnitude that we are talking. So it will be just 7.5 Newton second. That's the answer. Is that clear? Is that clear, everyone? Come on, let me know. I hope you understood your mistake. Did you guys understand your mistake? What had to be done? Yes, yes. So sign was not important, just the magnitude was asked. So this was the correct answer. Very interesting. Very good, guys. Very good. So going to the next question coming up on your screen now. So there is a graph given. Understand, each block's height is 2 Newton, but each block's width is 1 second. So keep that in mind. The graph goes till 4 and that is at 3 seconds. If you want, I can write down the times in case you're not able to see it clearly. Alright, so this is 3, this is 4, this is 5, and this is 6. And this will be minus 2, and this will be minus 4. Alright, that's how it is. What is the impulse in the first 7 seconds? Let's see how many of you get this. I'm starting the timer now. Come on, guys, you have to get it. Most likely it is not going to be 0. Let's see how much it is. Come on, guys, you have to do this. Come on, come on, come on, come on. Come on, everyone, come on, come on, come on, be careful, be careful, be careful, be very careful. Again, I'm telling you, be very careful. I'm showing you the graph, I'm standing here so that you can see the graph. Come on. Lot of you have given the wrong answers. Very few people have given the correct answers. Very few. Very few have given the correct answers. Science Priya and Janvi, I think, and Uncharted maybe have given the correct answers. Let's see whether they are correct or not. So guys, force time graph is given. What is the impulse? Now what is impulse? Impulse is nothing but area under the force versus time graph. So this is a force versus time. So we are good to go, but be careful. Understand, this area is positive because it is on the top, whereas this area over here is negative. Be careful. So when you add the areas, you have to account for the signs. That's why I gave you this problem. So if I ask you, what is the area on the top? Well, it will be half into the base, which is 4, into the height, which is also 4. So it will be 4 2s are nothing but 8. So that's what it will be on the top. But if I ask you what is the area over here, that will be half into the base of the triangle. Think about it, it is 2 units, into the height is 4 units. So it will be, actually speaking, minus area, so it will be minus 4. So hence, guys, if I ask you what is the impulse, that will be 8 minus 4, which is just going to be 4 Newton second. It's not 12 or anything else. I hope you guys got that catch, the trick, the trap which was laid for all of you to fall into. Pupula, it is not 0. It is not 0. Okay, it's not cancelling out. I hope you got your mistake. Very good. Sir, mathematically area cannot be negative. No, area can be defined to be negative graphically, in graphs, not the physical area. So this area is not that area of your palm or area of a square. No, this is the area which represents some physical quantity. So that area can be negative to us. Okay, I hope this is fine. It's not a physical geometrical area, understand? That's a different thing. Obviously those areas are always going to be positive. All right, yeah, very good Ashutosh, very good Shobna. Okay, so here is your next question. Let's see how many of you get the correct answer. You are 60 kgs and you are running at 3 meters per second. This is a very tricky question, and you bump into a wall. The wall stops you in 0.02 seconds in situation 1. So you go hit and you stop in 0.02 seconds. That's situation A. Second situation, the wall is padded with some soft material, so you end up stopping in 0.05 seconds. So you stop in 0.5 seconds, my bad. In which situation is the impulse higher? Come on, is it A, B? What do you think? Come on. No problem, no problem. Come on, come on, come on, come on. Is it A or is it B? Come on, I'll just show you the slides again. Just see this properly. Jay, what did you not understand? Is it A or is it B? Come on, let me see how many of you get the correct answer for this. Come on, this is not so difficult. Okay, let me tell you guys. Let me break the news. Should I tell you the answer? Should I tell you the answer? Should I tell you the answer, guys? Very good. Few people have got it correct. Like Uncharted has given the correct answer. The answer is same. Yes, the answer is same. A lot of you people got confused. What did I tell you? There is a difference between impulsive force and impulse. Impulse is not the same as impulsive force. I just told you that and you guys got confused. Guys, what was the initial momentum? Initial momentum 60 multiplied by 3. What is the final momentum? Well, that's at rest. So obviously it's 0. So 60 into 3 is nothing but 180. So if I ask you what is the impulse, it is nothing but final minus initial. So final is 0, so it is 180. Where is time? Where is time? Tell me, where is time? Is there time? No. So what does it mean? Impulse is the same. But you know what? What is different? The force is different. Yes, the force is different. In situation A, he stops suddenly, so the force will be higher. But in situation 2, the force will be quite less because time is more. So understand, impulse, where did it go? Yes, impulse was also force multiplied by time. So in situation A, time was less. So when time is less, then the force will increase. That is different. So the question was, where is force more? Then your answer will be A. But if the question is, where is impulse more? The answer will be same. What a question. Yes, he upgraded himself to IIT Bombay. Got it, guys? Got it? Yes, do not worry. Do not worry. Do not worry about the answers, guys. You have come here to learn, and that is what you're going to do, and that's my promise. Alright? So stay tuned. And let's go to the next question coming up. Now this is going to be a very interesting question. Let's see how many of you get this. If you crack this question, your seat in IIT is pakka. Alright? So let's see how many of your seats are getting reserved today. Yes, this is a seat reservation question. Let's see how many of you get that. Are you guys ready? Are you guys ready, guys? Because this is a very tricky question. Seat reservation. Alright, so observe that billiards. Now it's going almost like angle of incidence is angle of reflection, but that need not be true all the time. In the next question that I'm going to ask, angle of incidence and angle of reflection may not be the same, and that's what you're going to see. And let's see how many of you get it. A pool ball hits the edge with a speed of 10 meters per second at 37 degrees with the normal. Alright? And bounces off the smooth surface at 45 degrees reflected angle. If the ball weighs 0.5 kg, what is the impulse by the surface? Come on, let's see how many of you get it. I'm going to give you 2 minutes. Take 2 minutes, no problem. And let's see how many of you get it. Let's see. Come on, come on, come on. Physics lover, I have already done that. In fact, if you see one of our previous old videos, we have given the strategy for 2022-2021. We have already done that. So please go back in our playlist, you will find it. In fact, we have done a lot of sessions on that, how to study and all that. It's not Ashutosh, try it. Do not give up so easily. Come on, Pramati, Krito, Jumna, Uncharted, Johi, Sanspriya, come on. I do not know the answer. I'm not going to tell you the answer whether it is correct or wrong, but you have to figure it out. Come on. I'm going to move out of the screen so that you can see it properly and solve it properly, but I'm going to keep motivating all of you. Come on. Come on guys, you can do it. Because you will get almost 2 minutes only in the examination. That's why I give you 2 minutes. In fact, I give you slightly more time because I read the question for you. Nobody is going to read the question for you in the actual exam. Jay, there is nothing like weightage because this is not boards, right? So Jay is free to take as many questions or as many chapters as it wants, and sometimes the question can be mixed. So telling you the weightage will be wrong, and if somebody is telling you what is the weightage of this chapter, they are lying. Okay, so understand, true weightage cannot be told. You can just guess, okay, so many questions is the trend, so I can just give the trend, but there is no hard and fast rule. Okay, the time is up, and now let's talk about this question. So the most important word in this particular question is smooth surface. Understand, when the ball hits over here, it will experience some force. Maybe, I don't know, I'm just guessing, the force, assume it is in this direction. Now that force will obviously have two components. One is Fy and one is Fx. In fact, this Fx is friction, okay, and this Fy is nothing but normal, correct? So this is normal and this is friction. So think about it. If the surface is smooth, will there be any friction? Obviously no. Will there be any Fx? Obviously no. So will the net force be at an angle? Obviously no. So where will the net force be? Perpendicular. I hope this logic is clear. Alright, so the net force is going to be only in this direction. So now that means, think about it, if the force is going to be in this direction, obviously even the impulse is also going to be only in this direction. So the only impulse that will be there, all right, is going to be the impulse in the y direction, since impulse in the x direction is 0, and the reason for that is because it is smooth. This should be clear in everybody's head. Is this clear? Is this clear? Is this clear? First concept. This is the first concept in this problem. Let me know, guys. Come on, give a thumbs up. Tell me yo, yes. Is it clear? Very good, very good. Amazing. Now comes the next part of this. If that's true, let's think what is happening initially. So initially, the momentum which is there, the velocity is 10 meters per second at 37 degrees angle. So this angle over here is 37 degrees. So what is my, I'll just write it here, initial momentum 0.5 kg into 10, right? So that is just going to give me 5. All right, so that is just 5 kg meter per second. Now that 5 can be resolved into two components. One component here and the other component here. So think about it. If this is 37, this will be also 37. And what will this be? This will be 5 cos 37 degrees. What is 5 cos 37? Cos 37, guys, it's 4 by 5. So it is going to be 4. That's what this will be. If this is 4, this is going to be 5 sine 37, which is going to give me 3 units on this side. I hope this is fine, everyone. Alright? Alright? Don't worry, don't worry. I never said if you do not solve this question, you are not going to get IIT. I just said if you solve this question, you will get IIT. Even if you don't solve, If you stay with us, then definitely you will crack IIT. Do not worry. I'm going to make you get there slowly. We are going to slowly reserve all your seats. AK question, you will see all your seats will get reserved. All right. Now, the next part is, when it rebounds, which momentum will remain unchanged? Will this 3 will remain unchanged or 4 remain unchanged? Think about it. 3 or 4? Think about it. Is it 3 or is it 4? How much is it? Yes, the 4 component will remain unchanged. Correct. Because X component, remember, is going to be unchanged because there is no momentum. There is no force in the X direction, or the impulse in the X direction is 0. So, in this red part, understand, it will still have that 4 over here. But since this angle is 45 degrees, correct? This angle is 45 degrees. The Y component must also be 4 units. I hope you can see that. The Y component, my bad. I said 4. My bad. It's 3. Horizontal component is 3. My bad. Alright, the horizontal component was 3. Yeah, the horizontal component, not 4. 4 is vertical. Vertical is definitely going to be changed. Only the horizontal will remain unchanged. Alright. So, that 3 will remain as it is. And both Y component and X component will be equal only because this angle is 45 degrees. Now our job is done, guys. Yes, our job is done. Believe me. You'll be like, sir, how is it done? Please let me know. Say guys, our total impulse is only the impulse in the Y direction. And what is the impulse in the Y direction? Final momentum in the Y direction minus initial momentum in the Y direction. What is my final momentum in the Y direction? Well, that's 3 minus. What is the initial momentum in the Y direction? Well, that is minus 4. So what is 3 minus minus 4? Isn't it 7? So 7 kg meter per second. That's the answer. Interesting, right? So it's not 1. A lot of people again do a mistake. 4 minus 3. No. Direction. How can you forget it? Do not forget the direction, guys. Yeah, be careful. I hope this is clear. Alright, guys. Very good. Got it. Very good, Uncharted. Very good. Krito, I guess you made the mistake. Yes. So Lakshit, whatever you did not get, please let me know which part you did not get. Or else I'll be moving to the next slide very quickly. Alright. Cos 37 value, you need to know this triangle. Alright, I have given you this trick before, but if you do not remember this trick, I'll tell you again. So, this is 3, this is 4, this is 5, this is 90, this is 37. And obviously this is 53 degree. Just remember this triangle, you will get everything. So, cos 37 is 4 by 5. You can see that. Alright, I hope this is clear now. Okay. Done. Very good, Lakshit. Bahut hi badhiya. I'm proud of you. Very good, kid. All right. So now let's talk about average force, guys. Let's talk about average force. Now, it so happens sometimes that your force is not constant. It varies. But I want the average value of that. So how do I find the average force? It's very simple. I'll tell you what you should do. See, imagine I have been given a graph. This is force and this is time. And this graph is variable because the force is also variable. Okay? So this force, the red line, is a variable force. It changes. Now, let's say this is time t. I want to find what is the average force. Okay, I want to find the average force. You know what I'm going to do? First, find the area under the graph. That is this one. So think about it. This area, alright, the area under the red graph, which will be integral f dt, is going to give me change in momentum of that body from 0 to t, of course. I hope everybody gets this. 0 to t, if I integrate it, I'll get what change in momentum this force, variable force, has caused. Alright. Now what is the meaning of average force? Here it is. If I tell you I need something called as the average force, then average force should cause same change in momentum in same time. If it causes the same change in the same time, only then I can call it average, guys. Okay, so I know it will be somewhere in between. So it should be one constant value, keep that in mind. So maybe it is something like this, and it acts for the same time, like that. Now, if I measure this area, all right, if I measure this area, then if these two areas are same, only then that force is average. Understand that, because this area will give me impulse by this green force and red force ka area. If both of them are equal, only then their impulses are same. So what is the impulse by this? What is the impulse by this guy? Think about it. It will be delta P, which is just height, which is just F average multiplied by the time, which is just T. Isn't it? Isn't it height into time? Isn't it average force's impulse? Is that clear? Very good, very good, very good. Very good. Very good. Excellent. I would request the moderator not to spam, please. Yes, Suhas, I just saw. Whosoever is handling the chat box, please do not spam. I'm guessing they have. I'm guessing, you know, maybe it's gone into some autopilot kind of a mode. It might have been done by mistake. I'll just message them. Just hold on. Just hold on. Okay, Adu. Please don't spam, and make sure that. Oh my God, why is this happening? This is unheard of. I'm facing this issue for the first time, guys. Don't spam. Yes, I'm not sure why this is happening. So guys, ignore. I have just messaged. Okay, just ignore. For some time I just messaged them, but let's see. Let's see. Okay, just ignore. Okay, so guys, do not lose track. Do not lose track. I was just saying that the change in momentum is F average into time, right? That's what it is. Now both these delta P's should be same. That's what it says. So just imagine I'm going to do a beautiful trick. Beautiful trick. Just observe this. Where did my... Yes, this is where it is. Yeah. So just see this. On the LHS, I will have F dt, and this is 0 to t. Correct? 0 to t. And this will be nothing but average force into time. Now rearrange this. Yes, rearrange this. What will you get? You will get average force is equal to, you will get average force is equal to this term divided by time. So let me do one thing. Let me remove this. So you will get average force as this integral stuff, integral F dt from 0 to t divided by that time over here. That's it. I have found the definition for average. So you should know this definition, guys. This is one way of looking at it, and let me tell you another simple way of looking at it. What is another way of looking at it? F average. What is the numerator? Isn't it impulse? That's why I taught you impulse. It's impulse divided by time. So that is another way of looking at it. So if impulse is given and time is known, that's it, you get the average value. I hope this is clear. So Suhas, I just said, if there is a variable force, it creates some impulse. What is the impulse? Integration, force with respect to time, that red area. What is average force? Average force is that force which acts constantly for the same time and it produces the same change. So what is the area of the green graph? Height into base, that's it. Now if I equate both these delta P's, what will I get? This integration term is equal to average force into time, correct? Now taking time below, what did I get? This integration term divided by t. So that's the definition of average, and we know the value of the numerator is actually the impulse. So that's another way of looking at the same formula. I hope it is clear now. Is height provided in the question? You will be given an equation. That's the best part. Either you will be given a graph or you will be given the equation of the force. So either one of them will be given. I hope this is clear now. Amazing, amazing. Kamlesh, focus on the lecture. whatever questions you have, whatever doubts you have, you can always put in the comment section, not in the live section, right? The comment section, which is below, it opens up only after the lecture ends. Remember that. All right. So let's do a question, guys, on average forces. Come on. Let's see how many of you get this. Let's do a question on this. An automatic rifle is firing 4-gram bullets, very small bullets, into a wall at a rate of 60 bullets per minute. 60 bullets per minute, that's how it is firing. And the bullets impact the wall, moving with certain speed, and it gets embedded in the wall. And then, what is the time averaged force exerted on the wall by the bullets? That's the question. Come on, think about it. Come on, think about it. I'm going to give you 1 or 2 minutes out here. I'll give you 2 minutes, not more than that. Come on, do this. Come on, guys. Be careful of the units. Come on. Some of you have got it already. Come on, guys, think carefully. 30 more seconds approximately left. Come on, you can do this. Okay, 20 seconds left. Don't worry, don't say maybe. If you got it, just put it off. You have to be confident, because in the actual examination you cannot say, oh, maybe option B. Examiner is not going to give you some extra marks because you wrote maybe. So you get it or you don't get it, don't worry. Alright, so let's see what is the answer. The time is up. Okay, so now the mass of the bullet is 4 grams, alright, and it hits the wall, alright, and how many bullets are striking? Well, 60 bullets are striking per minute, alright, so let's keep that in mind. Now think about it. Each bullet has some mass. It's moving with some velocity u, and when it hits the wall over here, alright, that bullet stops. That means it comes to rest. So let's think, what is the magnitude of the change in the momentum of one bullet? Alright, so this is for one bullet, I can say. So for one bullet, delta P1 will be equal to mu minus 0. That's it. Or actually I should put modulus, so it's final minus initial, so it is just mu, strictly speaking. Now understand, it's not just one bullet, many bullets are coming, so we'll keep that in mind. Now if I want the average force, what did I say? It is just impulse divided by the time. So what is the impulse? Impulse is nothing but the change in momentum of all the bullets together divided by the time for which these bullets are hitting that wall. So now, can I not say the change in momentum of all the bullets is number of bullets multiplied by the change in momentum of one bullet divided by the time? Now think about it. What is this term? What is this term? This is the number of bullets which are striking per unit time. Number of bullets per unit time. And how much is it? 60, but that is per minute. I have to use SI units. So if it is 60 per 60 seconds, so it is 1 per second. So hence this term over here is actually 1. This delta P1, I know what it should be. It will be 0.004 multiplied by U. U is 200. So that is what it is going to be. So substitute it over there. So 0.004 multiplied by 200, and that is going to give you, I guess, 0.8 Newton second. Just check this out. Oh, sorry, Newton, my bad, not Newton second. Just check this out. All right, amazing. Did you guys get it? Understood how to solve this problem? It's not 8, it's 0.8. This is clear. Very good, very good, very good. So that's the average force. Now I feel that this average force is quite less. So do not expect the person to go back with a huge force, because the mass of the bullet was very less. The speed was not that great also. It's 200, it's fine, okay. And the number of bullets were also not so huge also. 1 bullet per second. There are rifles which can shoot more than 2 or 3 bullets per second. So that will create a huge recoil force on the person. All right, very good. In fact, I have seen one question in JEE Advanced where the question was, if this is the force on the Pandu who is firing those bullets, what should be the coefficient of friction on the legs so that Pandu does not slide back? Yes, what a question it will be. And I believe now you will know how to solve this question, because if this is the force acting on him, then you can just equate it to mu mass of Pandu multiplied by G. So you can equate it to that, and you can easily find the coefficient of friction between the legs and the Pandu, legs and the ground. So that will give you the answer. So that's the minimum coefficient required so that the Pandu does not slide. I hope this is fine. Clear, clear, clear. Yes, maybe you'll survive. So next question is on integration. So there is a function over here. The force varies with time, given by -3t square plus 60. This is a force, it's a variable force. Remember that graph I had showed you, variable force. Force is in newtons, t is in seconds. What is the impulse imparted to the body during the time interval 0 to 2 seconds? That's the question. And what is the average force as well? Let's see how many of you get it. I'm going to give you, I'm going to give you 1 minute for this. Or maybe chalo, I'll give you a little bit more than that. I'll give you 1 minute and 30 seconds for this question. It's not that difficult. Come on. Uh, 17 has heard me 60 bullets per minute. Like I think Krito also has said, 60 bullets per minute is 60 bullets for 60 seconds. So 60 by 60 is 1. That's how it became. Very good, Krito. Good, you're helping. Well, Sai, ready? Get to business. Come on, start solving. Okay, Science Priya has given some answer. We do not know whether it is correct or wrong. Let's see, do not worry. Come on guys, I have one more good question for all of you. Ashutosh, what else do you expect? If you don't have questions, then what is the point? Okay, Sneha has given some answer. So concepts have been already taught and concepts are developed via questions, Ashutosh. So this is JEE, this is not a board class. You know? So in board classes you just have theory, and concepts are clear only via questions and the first theory. Alright, so let's get going. And now here is the thing, the net force on the body varies with this function. So let's see, what do we do? What is the impulse? Okay, so we know that impulse is integration of force with respect to time. So let's put the value of the force. The force is minus 3t square plus 6t and dt, and the interval has been already given 0 to 2. So split this integral first and take out the constants. So this will become minus 3 and you will have t square dt plus 6, and you will have t dt. Obviously the limits will be 0 to 2 and 0 to 2. Alright, now just perform your integration. What is the integration of t square? T cube by 3. Alright, so it will be minus 3 and you will have t cube by 3. I hope you remember these stuff I have taught you in integration. Lower limit 0, upper limit 2. I just put it over there. Plus 6. Integration of t raised to 1 is t raised to 2 by 2. So this will become t square by 2, of course, and this will be 0 and this will be 2. Okay, now what to do next? Let's substitute the values. So the impulse will be equal to minus 3 and you will have 2, you should substitute over here. So it will become 2 cube by, oh sorry, that's 3, my bad. 2 cube by 3 minus 0 cube by 3. I'm just doing all those steps so that you recollect all those definite integrations and stuff like that. So here you will have plus 6 and here you will have 2 first. So it will be 2 square by 2 minus 0 square by 2. So let's see this. I believe this 3 gets cancelled. So it will become minus 2 cube, which is 8, plus one of those 2's will get cancelled, and 6 into 2 is nothing but 12. So minus 8 plus 12 is nothing but 4. So the impulse answer is 4. Alright, and that will be kg meter per second. I hope this is fine. Very good. Very good. Yes. Very good. Now, what is the next part? What is the average force in that 2 seconds? So, how do I get that? We know what to do. Average force is nothing but impulse divided by time. So, just substitute. Impulse is 4. What is the time? 2 seconds. So, what will be the force? 2 Newton. So, 2 Newton is the average force. That's how you do it. Yeah, that's the answer. Very interesting. That's how you solve problems based on the graphs or even equations. What an interesting question. Alright, shall I erase it? Shall I go ahead? Perfecto! Amazingo! Excelente! Let's go ahead. If this is an excelente problem, let's go ahead. Yes, very good. Excelente, guys. बहुत ही बढ़िया. How about this? I have some question. I feel I should give it to you as homework. What say? Will you do this as homework? Will you do this as homework? What say? I'll post up the solution. You know where? Where am I going to post the solution, guys? Where am I going to post the solution? Science Priya, not Newton per second, because force is Newton. In fact, impulse is Newton second. Alright, so Newton second by second, second goes and it will be only Newtons. Yes, Telegram, correct. So you should join the Telegram group. I'll be posting the solution of this. Let's see how many of you get it. Post the answers in the comment section below, or you can post it on my Instagram handle, of course, if you want to. It's up to you how you want to do it. The slide will come up. I'm just showing you the slide. Just take a screenshot of this. Just take a screenshot. Alright. Yes, Telegram. Very good, guys. Now, for all the 12th and dropper students who do not want subscription, I have second option for you. Yes, all the dropper and the 12th standard students who do not want a subscription can go exclusively for the crash course, only crash course, where you also get the test series, you also get the assignments, you also get live classes and the recordings and the PDF sessions and the doubt section and also post-class doubts, pre-class doubts, whatever you want, everything. And this course is a cyclic course, meaning even if you join today, you will not miss anything, because whatever you have missed will be taught at the end. It's a cycle. Like there are modules 1, 2, 3, 4, 5, 6 till 10. Let's say you're joining in the 4th module. You'll be like, so what about the first 3 modules? Don't worry. After the 10th module is over, teachers are again going to start with 1, 2, 3, 4, 5, 6. So it's a cyclic course so that you do not miss anything. That's the brilliant way of planning and how Vedantu plans, so that nobody misses out on anything. And you'll always get the live courses. So how do you join it? The link is again in the bio or the description, and the course price is just 10,000, but you will again get 20% off just like usual, and you will get it for only 8,000 rupees. That's a brilliant move. 8,000 rupees mein tumhara April tak, everything till April will be done. JEE Main's first attempt, second attempt done. Alright, so I feel you should join it. And Telegram group, again the link is in the bio, and if you have loved this session, please like it. Go ahead, like it if you're not liked it yet. And if you're a new student, obviously, well, you know what you should do. You should go and subscribe, or else you will not get all the new updates and you will miss out on all the important stuff to crack the JEE examination. Amazing, Kofida. Very good. Very good. Techno. Kya baat hai? Very good. Arey Suhas, do not worry. Amazing teachers are there. And I'm glad you love me. I'm so glad, guys. Thank you very much. Thank you, Science Priya. Thank you, Jumna. Bye, Techno. Bye, bye, Fida. Take care, guys. See you soon. And tomorrow, the next class will be on conservation of momentum at 7 p.m. And all the 12th standard students, do not worry. We are going to be back with electrostatics on Thursday. So Thursday will be electrostatics. Remember, again, continue. Potential energy, satellites, Kepler's laws. Everything will be taught to you. Do not worry about it. All right. So bye-bye, guys. Take care. Signing off. This was Shreyas here, your master teacher for physics. Bye-bye.